Okay, so today we're going to be solving linear inequalities, which is very similar to solving linear equations with just a few little, mainly one extra rule in there. First of all, let's point out that we have the less than and greater than sign, and less than or equal to and greater than or equal to. And just keep in mind that the point is always pointing to the smaller number. All right. So first, we're just going to practice with graphing inequalities. We've got x is greater than negative 2. So to graph that, I'm just going to put a few numbers. Oops, I meant to do something else there. I'm going to put a few numbers. I'm going to put negative 2, 0, and 2. So I want to show all the values of x that are bigger than negative 2. So I'm going to shade everything to the right, and then I'm going to put an open circle right here. Okay, example 2, we're going to show all the values for x that are less than or equal to 4. So again, I'm just going to make a little number line. Alright, so I'm going to show the values of x that are less than or equal to 4. So I'm going to put a circle at 4, shading everything to the left. Those are all my values that are smaller than 4. But this time, because I have the equal to sign underneath it, I want to show in my graph that 4 is a part of my solution. So I'm going to color in the dot. Okay, so let's look at example 3. This time, we want to show the values of x that are bigger than negative 1, but are smaller than 3. Okay, so let's pick some numbers and figure out if they are part of that graph. Let's just pick some random numbers. Okay, negative 4. Negative 4 plugged in for x right here. Negative 4 bigger than negative 1? No, that is not true. So that's not part of my solution. All right, let's look at negative 2. Negative 2 is smaller than 3, but it's not bigger than negative 1. So that one doesn't work either. All right, so if I look at 0, 0 is a number that is smaller than 3, and 0 is bigger than negative 1. So 0 is a part of my solution set. All right, well, what about 4? 4 is not smaller than 3, so that cannot be a part of my solution set. So basically what I'm looking at, if I look at my number line, I need everything to the right of negative 1, but to the left of 3. Those are all the values of x that are going to fit that description. Less than 3, but bigger than negative 1. Now, because it's bigger than negative 1, not equal to, I'm going to leave an open circle. And since it's less than 3, but not including 3, not equal to 3, I'm going to leave an open circle there as well. All right, example 4. This one says to graph the values of x that are less than or equal to negative 3 or greater than 2. So if I look at my values that are less than or equal to negative 3, that's going to be like negative 4, negative 5, everything to the left of negative 3. And then it's going to be a closed circle. This is what I mean by closed. It's filled in at negative 3 because we are including negative 3 with the equal sign, half equal sign. Okay, and then where x is greater than 2, about right there-ish, all the numbers that are bigger than 2 for x. So that's going to be everything to the right. Now, it's not including 2 this time, so I'm going to put an open circle at 2. Now, notice the difference between your OR statements. This is what we would call an AND statement. AND statements always look like this. Everything in the middle is what colored. OR statements, x is less than this or bigger than this, always look like this, where they point out. All right, inequalities work the same as equations, except that when we multiply or divide both sides by a negative number, the inequality symbol has to change directions. Okay, so example 5, I know most of you, when you solve equations or inequalities, you don't like your x value to be negative. So let's start by moving the 3x to the right side. So that gives me 1 is greater than 2x minus 2. Okay, now to move everything away from the x, I'm going to add 2 to both sides. So it gives me 3 is greater than 2x. So last step would be to divide by 2. So that basically says 3/2 is greater than x. Now inequalities are a little bit fishy, basically. To read it correctly, we would need to flip-flop it. X is less than 3/2. It doesn't matter what side the x is on, but we usually like to have it on the left. Okay, example 6. All right, so I'm going to subtract 1 from both sides to solve for x, so that gives me negative 3x is greater than or equal to negative 15. Now I'm going to divide both sides by negative 3. That gives me a positive x and a positive 5, but because I divided by a negative, right there, that negative 3, I have to follow my rule and flip that inequality and make it less than or equal to. Alright, so then x is less than or equal to positive 5. Okay, number 7, a word problem. Yay! You have $30 to spend at Wurstfest. Admission is $8 and rides are 75 cents each. Describe the number of times you can ride the rides. Okay, so we're on a budget at Wurstfest. We know that no matter what, when we go in, it's going to cost us $8. And then for each ride we want to ride, 75 cents. So, and we cannot spend more than $30. All right, so our equation or inequality is going to have to be this: 8 and then plus 75 cents times however many rides we ride. And that's what we're trying to figure out. So I'm going to subtract 8 from both sides. That leaves me with 0.75x is less than or equal to 22. And I'm going to divide both sides by 0.75. So then x is less than or equal to 29.3 repeating. In other words, you have to keep yourself from riding more than 29 rides. Okay, number 8, it says to solve an and inequality and then graph the solution. Okay, so I'm going to show you 2 different ways to do this, but then I'm only going to solve it by the fast way, which I'm sure y'all will appreciate. So basically what we're looking at here is 2 separate inequalities. We've got negative 4 is less than 6x minus 10. And then we've got 6x minus 10 is less than or equal to 14. We have to split this up to find the values for x that make both of those statements true. So, 2 ways you can do this. Negative 4 is less than 6x minus 10. And then you can make a second equation, 6x minus 10 is less than or equal to 14, and solve both inequalities for x. Or you can do it the fast way, keeping in mind that these are both 2 inequalities. 6x minus 10 less than or equal to 14. And we can add 10 to both sides, which, since we're technically doing 2 equations, that really means 3 sides. So it's going to be 6 is less than 6x, that cancels out, is less than or equal to 24. Last step to solve for x, I'm going to divide everything by 6. So 1 is less than x is less than or equal to 4. So now when I graph that, here's my 1, here's my 4. Close circle at 4 because it's equal to. Eesh. Open circle at 1 because it's not equal to. And then everything in the middle. And then again, because it's an and, it's going to be everything filled in between. It's the way those graphs always work. Okay, number 9, it says solve the OR inequality and then graph. Okay, there is no quick way to do this. I have to solve both of these inequalities one at a time. So I'm going to start with x plus 4 is less than or equal to 9, and I'm going to subtract 4 from both sides. So that's x is less than or equal to 5. And then on the other side, add 3. So x is greater than or equal to 10. Okay, so if I were to graph that, here's positive 5 because I said so, and there's positive 10 because I said so. Close circle at 5, everything filled in to the left. Close circle at 10, everything filled in to the right. Okay, number 10, we're going to solve and graph. This is an and, so rather than splitting it up, we are going to solve both equations, both inequalities at the same time. So I'm going to subtract 7 from all 3 sides. Cancel. Negative 8 is less than 2x is less than 12. Now I'm going to divide everything by 2. So it's going to be negative 4 is less than x is less than 6. Okay, now to graph that, negative 4, positive 6, I need all the numbers for x. That are bigger than negative 4, so open circle and to the right, and then everything smaller than 6, so open circle and to the left. And there's my values for x that make that inequality true. Okay, so just don't forget the trick with inequalities is when you divide by a negative, you have to divide or multiply by a negative, you have to flip the inequality. And we're going to spend a little bit of time looking at why we have to do that in our journals.